Welcome to Module 8. In this video we zoom out from a single printed buckle and look at the whole factory. You will learn how body scans, virtual samples and smart machines join up into one quicker, cleaner textile workflow. The traditional garment path is long: sketch, pattern, sample, freight, feedback. Digital tools turn that line into a loop where data moves faster than fabric, saving weeks and tons of CO2. Step 1 is a body scan. A depth camera costs no more than a smartphone. It captures a cloud of tiny points that become a 3D avatar, the digital twin of a real body. We tidy the scan in Mesh Lab. Fill tiny holes, smooth spikes, center on origin. This watertight mesh is now ready for pattern software or virtual try-on. Beginners can do it in 10 clicks. The designer drapes virtual cloth on the avatar. Strain map turns red where the jacket strains, blue where it sags. Fit issues surface before cutting a single centimeter of fabric. Data lets us shrink a size set. One pilot reduced 7 sizes to 3 core bodies, trimming sample waste by 12%. Less fabric, fewer complaints, happier buyers. Need realistic fabric? Download a Fab Set card. It stores weight, thickness, stiffness, stretch. Drop the card on the garment. Now the simulation hangs like real cloth. Color matters. Embed an ICC profile so every screen shows the same red. No more, looks great on my monitor, arguments. Export a GLB. It packs geometry, material, textures in one file small enough for email. A buyer can spin the garment on a phone. No sample parcel, no customs delay. Pattern pieces leave CLO3D as DXF. The laser reads DXF and cuts fabric exact. Grain lines, notches, even QR codes travel inside the file. No paper, no tracing. Trims travel as STL to a desktop printer. In 1 hour you print zipper pulls, cord locks, logo badges, color matched and locally made. The sleeve knits fully fashioned on a flat bed. Data flows from CLO3D to STOL M1+, then to the machine. Waste cuttings drop from 15% to under 3%. Quick reference: DXF for 2D cut, STL, 3MF for print, STC, knit, ML for knit. Keep a clean master file. Export children, never re-import sliced children back to design. Plan with colors. A simple Kanban shows cut tasks in blue, print tasks in orange, knit tasks in green. Even a 3-person micro factory stays in sync. A digital Gantt compresses one prototype cycle from 10 working days down to 5. Laser and FDM run in parallel instead of waiting for courier feedback. 1 GLB email beats a 700 km truck. DHL research says 3D workflows can erase 20 to 60% of transport kilometers. Less fuel, quicker approvals. DHL names 5 3D deployment models. First is a spare parts cell. Imagine a printer at every flagship store turning out replacement buttons on the spot. Second is product postponement. Base sneakers printed in white, dipped to color only after the customer clicks buy, cutting dead stock. Third is the performance house, like Athens Knit Lab, making zero waste knit in one room, ready to ship worldwide. Fourth, end of runway lab. Printers sit inside a parcel gateway so an online order prints and boards the next flight in hours, not days. Material maturity drives adoption. Today plastic leads, but bio-based and recycled filaments grow. Protein-based trims may hit price parity by 2028. Watch this space. Designers learn logistics, ship filament or finished part. Locally printed trims cut freight, but some clients still need CE-marked items. Decide early. Small factory PLM, 4 folders. 1. Design read only. 2. Tech read write, for pattern team. 3. Sample feedback videos. 4. Master approved. Simple rules avoid ROM version chaos. Everyone sees the same master file in cloud. Comments stick to version. Changes track. Miscommunication shrinks, trust grows. Flat knit uses less fabric but can raise electricity. Smart motors sip single-phase power, lowering kWh by 30%. Data matters more than guesswork. 3D trims re-enter the loop. Grind failed prints, melt, re-extrude, print again. Closed-loop polymer hubs match EU circular textile targets. Teachers run a micro LCA comparing old and new workflow. Students see numbers, not slogans. 2 prototypes saved equals 2.4 kilograms fabric, 18 kilograms carbon dioxide avoided. If textures vanish, pack them on export. If file is huge, auto-load in Blender. Beginners learn that 80% of issues fix in 5 minutes. Knit cuff twists. Check gauge and take down tension, not pattern. Small steam block often cures the twist. No laser. Outsource cutting but keep digital pattern. You still save freight on trims and samples. Integration is modular, start small. Sofa story. Printed RPETG buttons. Zero waste layout. Refugee skills. 550 kilograms waste diverted. Shows how 3D can power social impact, not just efficiency. Athens Knit Lab. 1 thread, near zero waste. Export over 80% of output. Proof that microfactories can win global clients with 3D integration. Future Radar. AI fit engines that auto-grade per body scan. Protein filaments. PLM sockets that talk to live carbon trackers. Today's learners must stay curious. Recap for absolute beginners. 4 bookmarks. Scan the body. Fit the avatar. Approve the sample on screen. Export clean files. Everything else is repetition and practice. In the quiz you will label file types, pick the right ICC profile, and plan a 1-week digital production run. Use the glossary and cheat sheet if stuck. Digital harmony. Cutter, printer and knitter run together, feeding one sewing line. Lead time shrinks. Creativity grows because prototypes no longer cost a fortune. Case pilots show 5% higher margin, 30% less waste. Owners listen when numbers sing. Learners practice writing that one-page cost-benefit memo. Tomorrow's technician needs 3D fluency plus logistics literacy, designed to dispatch. Our MOOC prepares you for both. The next clip explains how our mentoring plans pair designers with makers, and how to navigate the full MOOC. Stay tuned. Produced under Erasmus plus SUST 3D Fashion. Remix, translate, share under Creative Commons by SA 4.0. Thank you and good luck connecting your smart factory.